constructing DFAs, there are some guidelines that you should keep in mind. Before you see any symbol, initially you are at initial state. Let that be Q0. So you start from the initial state and you look to get to the final state. So it is certain that you have to start from the initial state, and based on the language, you define the moves, you introduce new states, and you end up and you try to get to the final state. So this is one thing. This is part one. The second part is this. However many states that you are going to define in a DFA, each state represents something. Each state represents something. And what is that? Each state represents the set of strings traversed to reach that state. Isn't it? Because initially you are at Q0. You must see some symbol to go from Q0 to any other state. There has to be a move from Q0 to some other state. There may be a move from Q0 to itself. Based on what symbol you see, you follow this transition. So this is what is called as transition rules. Transition rules. Or change in configuration also. In DFAs, at any point of time you are at one of the state Q and you see some symbol. Means your tape head points to some symbol in the input head. So this constitutes a configuration. Okay. If you are at state Q1, it means that you have come to Q1 following some transitions from the initial state. Following some transition from this initial state, it means that you have traversed some strings in the input head. So each state represents the set of strings traversed to reach that part. Traversed to reach that state. And if the traversed string was the string itself, then it would end up always in this state. Okay, so Q1 represents the set of strings that will always end up at Q1. Q0 represents set of strings that will always end up at Q0. And similarly, if there is some final state QF, then this represents set of strings that will always end up at QF, and this is what is going to be the language of DFA. Okay. We will look at examples and these things will be clear. There is third guideline, and that is dead state. This third guideline, and it is about the dead state. So if you are at any state and the next symbol on tape head makes it certain that the string cannot be a part of language, regardless of what the remaining part of string is, then you give the transition to the dead state. Means that, let's say you are at a state, you are at one state, and you see any symbol A. So you have, so far, this is your tape head, this is your input head, this is your input tape. You have so far traversed some part of the string, let's say W, and you have reached to QI. QI, on seeing A, the string traversed so far is WA. Okay, and it is certain that WA and whatever comes afterwards, it does not matter. If you see A after this string W, it is certain that this string is not part of the language. Then what do? You give this transition to a dead state. You give this transition to a dead state. And what is a dead state? A dead state is that state where if you enter, you are stuck. So, what is a dead state? Dead state is, say this is a non-final state. Non-final state. plus all moves within itself. So if A and B are the let's say that alphabet is A and B, then non-final state plus all moves to itself. That's what the dead state is. Non-final state plus all moves to itself. Okay. Now let us take some actual languages and try to construct DFAs for it to make things clear. So let's take one language L1. Let's take a new page. So L1 is equal to, let's say, AA, BA. Let's say this is your language L1. There is going to be one initial state. L1 does not have epsilon, or L1 does not constitute empty string in it. So Q0, which is the initial state, will not be a final state definitely. Now Q0 on seeing A, Q0 on seeing A should go to another state Q1, right? Q0 on seeing A should go to Q1, and this Q1 is going to be non-final state. So one of the if this is a set of states, how many states so far? Q0, Q1. Okay. What is Q0? Q0, what does Q0 represents? Epsilon. I told you in the last page that each state represents the set of strings traversed to reach that state. So Q0 epsilon. What is Q1? If you see a on Q0, you will reach Q1. Okay. Now Q0 on B, when Q0 sees, when you are at Q0 and if the input symbol is B, then still there is a string possible. So you go to, from B you go to Q2. You go to Q2 because a string is possible. This is one approach you can take. Another approach, from Q0, whether you see or A or B, you go to Q1, right? Then Q1 will have A comma B, right? Let's say this is machine 1 and this is machine 2. This is machine 1, this is machine 2, right? Okay. Now you are at Q1. Q1 on seeing A. If you are at state Q1, it means the string traversed so far is A. If you see another A, then the string traversed so far is AA. AA belongs to the language, so whatever the state that you are going to define here, that state has to be a final state. So QF represents AA. Okay. Similarly for M2, when you are at Q1, it means the string that has been traversed so far to reach at Q1. When you are at Q1, it means that in order to reach to Q1, you must have seen either A or B from Q0. If the next symbol is A, what does this mean? It means that the string traversed so far is either AA or BA, right? AA, BA both are the part of the language. So you go to a final state. Okay. So QF represents in this M2 AA and BA both. Okay. Similarly, when you are at Q2, let's say when you are at Q1 in case of M1, when you are at Q1, you see a B. You see a B. Then it should go to the dead state. Right. Okay. When you are at Q2 and you see a A, then it should go to another final state. Sorry. Then it should go to another final state, because BA is also a part of the BA is also a part of the language. Now QF2 is BA. Okay. And then there is, okay, so you have defined move for Q0, you have moves defined for A and B. For Q1 you have moves defined for A and B. For Q2 you have move defined for A. What about B? If you see B when you are at Q2, it means that the string would be BB. BB is not a part of the string, and also it should go to final dead state. When you are at Q2 and you see a B, it should go to the dead state. Right or not? Because the string that you have traversed when you are at B Q2, it means that you have seen B. Another B, it is not a part of language, and whatever comes afterwards, this does not belong to the language L1. Therefore, you should give it to a dead state. Okay, so for Q1 also A and B defined, for Q2 A and B defined. What about QF1, QF and QF2? Okay. If you see any other symbol on QF1, the length of the string will become 3. After AA, if you see anything, the length of the string would become 3. And whatever comes afterwards, the length of the string would be 4, 5 and so on. Okay, so if you see any symbol at QF1, it means that the length of the string A belongs to L, that's okay. But anything after AA, length of the string is greater than or equal to 3, and that is not acceptable in L1. It means that whatever symbol you see at the final state, that has to go to the dead state. Okay, so M1 and M2 are two DFAs for L1. It means that multiple DFAs are possible for the same language, but the minimal DFA would be only one. So there is only one minimal DFA for a language, but multiple DFAs you can give for the language. Okay. So it's a good practice that while you are constructing a DFA, you try to construct a minimal DFA. Okay. Very good. Let's take another example. Let's take another example of finite language only. A, B, B, A, B, A, B, A, B. Let's take this language L is equal to A, A, B, B, A, B, A, B, A, B. So you must have an initial state Q0. When you see A, it should go to a state, and as I told that we will look to construct the minimal DFA. So on seeing A, it should go to a state, let's say Q1, and this Q1 has to be a final state because A is a part of the language. Okay, so this is dealt with. When you see B at Q0, then there is a string that is starting with B. So it should also, so Q0 on B should go to another state, let's say that is Q2, and there is still a chance that the upcoming strings may become a there is still a chance that upcoming string after seeing B, maybe the upcoming string will be AB, and that has to be accepted. So this Q2 is just a non-final state but not a dead state. Okay. When you are at Q1, if you see another symbol and that symbol is B, then it is also a final state Q2. Let's say this is Q3 and this is also going to be a final state because AB is a part of the language. When you are at Q1 and you see A, so you are still, when you are at Q1, it means the W that is traversed is A, and the next symbol you are seeing is A. AA is not a part of language, and anything that comes afterwards, after AA, anything comes, that is again not going to be a part of language. So from Q1, if you see A, it should go to a dead state. Okay. When you are at Q3, this is your final state. AB. If you see another A, there is still one chance of it becoming a becoming a string ABAB, which is a part of language. So you go to another state, Q4. When you see another B, then you go to a state Q5 and make it a final state, because AB is a part of language. When you are at Q3 and you don't see A, you see B. It means you being at Q3 means the string traversed so far is AB. After AB, if you see B, this is not a part of language. Anything that comes afterwards is not a part of language. So from Q3, if you see B, you go to a dead state. Similarly, when you are at Q4, the string that you have traversed so far is ABA. After ABA, if you see A, then it is not a part of language, and anything comes afterwards is still not a part of language. So Q4 on seeing A should go to a dead state. Same thing for Q5. What string you have seen so far? AB. Now anything that comes after AB, the length of that is 5 or more. So anything that comes after Q5 will not be a part of language, and so you go to a dead state. What about Q2? When you are at, so you have defined moves for Q0, Q1, Q3, Q4 and Q5. You have defined all the moves possible for these states. What about Q2? When you are at Q2, the string you have seen so far is B. If the next symbol is A, it means there is BAB is still there. So if the next symbol is A, then you should go to a state, let's say Q6. And if the next symbol is B, then you will accept it. Q7 will be a final state. And from Q7, it means when you are at Q7, you have seen BAB. Anything that comes afterward should not be a part of language. So it goes to QD. Now when you are at Q6, if you see A, when you are at Q6 means BA is there. BAA is not part of language, and anything that comes afterwards is not a part of language. Okay, when you are at Q2, you have defined moves for A. What about B? BB is not a part of language, and there is no possibility of whatever comes afterwards can be a part of the language, so it also goes to a dead state. So this is your DFA for this language L. So the two examples that we have seen, L1 and L, let's make it L2. These are finite languages. Okay, finite languages. So the observations that what I am talking about is, in case of finite languages, for finite languages, means DFAs for finite languages, number one, you don't see any self loop on a state, self loop or cycle, if states are non-final or final. Number two, self loops are there only on dead state. Okay, so this is the observation. If you look at this, from Q0 there is only forward edge going to Q1. There is only forward edges that is going. You don't see any cycle. It's not like from Q0 you are going to Q1 and from Q1 you are going to Q0. It's not like that. And you have self loop only in case of dead state. You have self loop only in case of dead state. Okay, if you see, there is a self loop on this state only, and this is a dead state. This is the dead state. On any other state, if you take Q1, Q2, Q3, Q0, or any non-final state like Q4, there is only forward move. There is no self loop and there is no backward cycle. The reason is simple. When you have self loop or cycle, it represents infinite language. Means, look at just see this. This is your state Q0. If you have, okay, just look at this. Just look at self loop or cycle. If you have self loop, let's say this is your Q0, A, Q1, and there is a loop B. Okay, now take any string, let's say W, A. Sorry, this is AB, B. Let's say W is equal to this, W1, W2 is epsilon, W3 is B. Let's say it is on B, it is going to a dead state. B, A. Okay, consider this. So we'll look at cycle in the next page. So in case of W1, which is A, let me take some spaces, good space, considerable space between the symbols. So in case of W1, let's say this is your A, B. Okay. So initially you are at Q0. Q0 on seeing A go to Q1. Q1 on seeing A goes to Q1. Q1 on seeing A goes to Q1. Q1 on seeing A goes to Q1. Q1. Sorry. Q1. Okay. Let me take W1. W2 is epsilon. Okay, epsilon. So what does epsilon means? Epsilon means in your input string this is khali. Epsilon means it is empty. Okay, so in case of epsilon, it is like this. You are at Q0. What about W3? W3, it is B, A. So you are initially at Q0. Q0 on seeing B will go to QD. In previous example, so if you can look at this, so if you look at this, this is your string and this is your state sequence. Okay, state sequence. The state sequence has repetition. So Q1 is repeating itself. So it's like this is your state sequence, and a state sequence has repetition. So in this example, we are having 1, 2, 3, 4 A's. but you can have as many as. The Q1 will keep on repeating. Q1 will keep on repeating if Q1 is the final state. So you can have as many states and Q1 will keep on repeating. It means that these are those many strings are part of the language. So do you understand what I mean? You have this is Q1. Q1 is final state. Q1 is final state. Q1 is final state. So on seeing A, you reach at Q1. It means A is a part of language. On seeing another AA, you reach at Q1. It's part of language. A is a part of language. A is a part of language. And this can go on. This is W1, which has 4 A's, but we can go on taking as many A's possible. It will still be at Q1, right? Similarly, after going through a sequence of A, you can have, after going through a sequence of A, as many A's as you can, as many A's as possible. You can have as many B's. It means that the language of this DFA, M, if this is your M, it means the language of M is an infinite language. It means the language of M is infinite language. W3, it starts from B, it goes to the dead state. It's clear that W3 does not belong to the language of M. It's clear. So you see QD, dead state, being repeated. Because in dead state, all those strings are there. Dead state represents all those strings that is not part of the language. So this is the difference that this is what I am trying to establish here. Okay, so what conclusion do you make? That you have for finite languages, self loops or cycle can't be possible except for dead state. So self loop or cycle can't be possible except for dead state for finite language, because except for dead state, because then the language will be infinite, and for infinite languages DFAs possible. So it is possible to give infinite languages. It is possible to give DFAs for infinite languages. DFAs for infinite languages using loops. That can be a self loop or that can be a cycle. So self loop is something like this, means on the same state, and cycle is something like this. From state, let's say Qi, you go to another state Qi plus 1, and from Qi plus 1 you go to a state Qi. Okay, so this is a cycle and this is a loop on same state, or you can just say self loop, and you can just conclude that for our infinite language, the DFA that we are going to construct will have the cycle and self loops. Okay, one more thing. If you see that in case of infinite languages, you will see the states repeating. This is one example of infinite languages. Where we have the self loop or the final state. You are seeing, that's why you are seeing final state to be repeated. But in case of infinite language, in the state sequence, you will see the states repeating. And these, because of this repeating, okay, 1 minute, I will deal with it. 1 minute. And in case of finite languages, the states will not repeat. In the state sequence, the states will not repeat unless it is a dead state.